So this is rotation about x-axis. So rotation about x-axis here. So if the rotation is about x-axis, your integral is respect to dx. And from here, you have to know two things. Integral is respect to x. And the next one is the selected disk is perpendicular to the x-axis. So how that helps you? Now, if the disk is perpendicular, you can see that the radius of that disk would be this length. This would be the radius. So, and that radius squared should come here. That radius squared should come here. Now, if you carefully go through the figure, that radius, this height would be the fx. Fx is the y value, right? Y is equal to fx. So this height is fx. So what we have to do is we have to replace fx here. Fx squared now dx. Now we have to check our boundary, lower boundary and the upper boundary. So the lower boundary and the upper boundary associated with x. So that would be, this is my x-axis, right? So that boundary would be here to here. So now here I will take this to be a and this to be plus a. So it is going from minus a to plus a. Okay. And that is the volume of revolution. So do you know that you can write this one as 2 times pi 0 to a fx squared dx, right? You can do that if the function is symmetric only. If fx is symmetric only, we can do that. Remember that. So I will leave this to you. You have to argue by yourself why we can use this if it is symmetric only, and I will leave it for you. Okay. Now we'll go for the next one. But before I go to the next part, I need to emphasize that this is volume of revolution. We get a volume, okay? So if it is in meters, I'm talking about meter cube. Volume, right? Now, how come you can see volume here? So pi r squared, these two will give you the area, and this dx part will give you the length, area times length is volume, right? You are integrating because you need to get the volume cumulatively. I hope you understand. Now the next one is rotation about y-axis. So rotation about y-axis. So that means, so let me draw this one. Suppose you have a figure like this. So the rotation is happening around this. Now, volume of revolution, right? So volume of revolution. This is how the VC people ask questions. Find the volume of revolution about y-axis. This is very easy. So once you have this one, you pay attention here, y-axis. So if it is y-axis, your knowledge goes to 2 different places. One thing is, this is respect to dy. The other thing is the disk should be perpendicular to, so here the disk is perpendicular to x, here the disk should be perpendicular to y. Now if you are rotating in this way, you can see due to that rotation, the curve will come to this, right? So due to rotation, you will get a solid of revolution. Now here you find the disk here. This is the disk. Now what you have to do is you have to have all of these in the figure. So the disk, this is the disk. Okay. Then, so suppose this is my minus B, here it's B, right? And this is your R now. Okay. So now the volume would be integration. You are integrating respect to Y. Now what would be your R? Pi R squared, right? So it's pi R squared. So what would be your boundary? The boundary would be minus B to B. Okay. So now what we have to understand is we have to find what is R here. So what would be the R? So you understand this, you have to find R, right? So this is an example. So we have to use our common sense to understand what would be R. You can see you are integrating respect to Y. So if you are integrating respect to Y, it is common sense that this R should be a function of Y. Right? So that should be a function of Y. Right? So in that case, this equation should be given as a function of Y. If it is given as a function of Y, that should be X. X is equal to G1. So then you can have phi minus B to B G of Y squared T1. And that is your volume of revolution about Y-axis. Now, there are two kinds of functions. Right? There are two kinds of functions. One thing is Y is equal to Fx. It's a function of X. The other one is X is equal to G1. How do you understand this? Think about the inverse functions. Inverse functions has this kind of a behavior, right? So when we get a question, we can take care of that. Now, we will do example here. Okay, question. Suppose you have Ex function. This is Y is equal to Ex. Right? Find the volume of revolution. Find the volume of revolution about x-axis, where x is between -1 and 1. So this is revolution about x-axis. So that means you should know it would be like this. That is the first thing. Boundary is specified already, -1 to 1. What would be your R? So you have to draw this a little bit and visualize. Now, the volume they're talking about is in between minus and 1. Right? And then you have to find the disk. I told you disk is, if you have X here, disk is perpendicular to X. So you take a disk like this. So when you take a disk like this, then you will see that this part would be your R. And you will understand that R is nothing but your function, Fx function. And Fx function is Ex. So R is equal to Ex, right? So it's going to be E2x. So once you do that, when you integrate this, you get by E2x divide by 2. I put 2 here, and then you put 1 to -1. So your answer would be by divide by 2, E2 minus e minus 2. So that would be the volume we are discussing here. So you can understand this is fx is equal to x squared. So volume of revolution about x-axis. So that means you have to have this. This is rotating around about x-axis. Right. So this is how the volume looks like. Now, to do that part, so I would say Vx, that would be pi. Now, Rx squared dx, I have to give the boundary 0 to 2. That's good. Now, what is Rx? So this is my, mirror, and this would be my disk. So I told you disk should be perpendicular to x. So in that case, this is going to be your Rx, right? So that Rx height would be is equal to x squared, right? So what you can do is you can replace Rx by fx. So Rx is essentially now fx. So you can see x squared here. So pi 0 to 2 x squared dx. That's very easy. So pi, you can see this one would be 3 x3 from 0 to 2, and that would be, if you put 2 here, 8 pi divided by 3, and that would be the answer. Yeah, so there is a mistake. The mistake would be here. Mistake would be here. So it would be 4 here. It's going to be 5 here. 5 should be here. So 5 should come here. So it's going to be, this is going to be not 8. That is going to be 2 to the power 5, which is 32. So this is going to be 32 pi divided by 5. Okay. Now, what about the B part? Now, B part, find the volume of revolution about y-axis. So in that case, it should go this way. Right. So now you are looking at this area. You are looking at that area. Okay, so you're looking at that area. Now, to get that area, so that area, to get this area, the base would be y. You can see that. The base should be y, right? When you are thinking about this here, you're rotating around x-axis, right? So your base is x, right? And you are looking at the height from here, perpendicular, right? Now, when you have something like this, you're looking at this disk. This is the disk. So you need this distance, which is r of y, this distance, right? So how do you find this distance? Now, when you have a function like this, if you get the point here, this distance is given by fx function, right? So this distance is given by y, which is x squared, right? So what about this distance here? This is x, right? So you have to say x is equal to what? That would be the distance. This one would be y is what? Why? Because this is y direction, right? So now here you get y is equal to x squared. So you need to get x now. X would be y square root. Okay, that would be y square root. So I will discuss that in a different way, but for part B, you need volume of y, that is pi, that's true, and this is dy. Now you understand if this is dy, this should be a function of y. Why something here? Why something here? And geometrically also you will see this is, this is y is equal to, this is x is equal to something in y terms, y in terms of y, right? So that would be y is equal to x squared. Here x is equal to y square root. So you put y square root here. Why? Because if you draw this is your radius, right? So that radius is x is equal to something, because this is parallel to x, right? This is parallel to x. So you get x is equal to something, right? So in other words, if you get this one, the disk is here. Now this one is parallel to y. So it would be y is equal to something. So that's why we got x squared there. Here we have to get this one. Then what about the boundary? So now boundary should relate to y. So this is the y lower boundary, y upper boundary. So y lower boundary is 0, y upper boundary should be this value over here. So when x is equal to 2, what would be the y value here? You put 2 here, it's going to be 4. So this is 4. So 0 to 4 is the y boundary. So knowing that, we put 0 to 4 here. Then what you get is y times 2 divided by 3, y 3 divided by 2, 0 to 4, base case number 1 integration. So 2 pi divided by 3 times, if you put 4 here, it's going to be 2, 2, it's 2, 3, 8.
So aren't you supposed to square the root y?
Yeah, so you are right. So this should be squared. Yes, you are right. I forgot that square thing. So in that case, life is easy, right? Pi, so it's going to be y squared, right? Yeah, because I forgot that square. So it's going to be 16 divided by 2 is 8 pi. Easy. Okay. So now let's think about this one now. Let's think about another easy one. Think about this, yeah. This function is y is equal to x, 0 to r, 0 to r. So find the volume of revolution about x-axis and y-axis. So 2 questions here. Okay, so this should be easy. First one, it would be pi 0 to r, function would be x squared dx. So it's going to be pi divided by 3, x3 is 0 to r. That is 1 divided by 3 pi r cube. Now we proved it. You remember when you do selective school or other scholarships, you used the equation of the cone is 1 divided by 3 pi r cube. Because when you do that, you get a cone, right? So when you revolve it, you get a cone. Now the b part, what would be the b part? So when x is equal to r, y also r, right? So the volume would be pi, again 0 to r, y squared dy. It's a very easy question. So again, you get the same answer. Okay. Okay. So now I'll go to the next page here. Okay. Then I'll give you this question. Suppose you have this curve. Here it's 1, 2, let's say 1 to 4 maybe, right? The function would be y is equal to log e base x, log e base x. Okay, so for simplicity, I will make this 1 to 1 to e. Okay, 1 to e. My first question is find the volume of revolution about x axis. That's my first question. The second one is find the volume of revolution about y axis. Okay, so the first one is easy because about x axis, right? So it would be like this thing. So this could be like this. The radius would be this, and the radius would be nothing but y because it's this way. So it's log ex is the radius, right? So this is r. So you can find that pi log ex squared dx, and that would be 1 to e. So that would be let's see, integration unit log x squared dx 1 to e. So so it would be e minus 2 pi. So it would be e minus 2 pi. So that's all good. Now, next one. Now, what you are going to do is you are going to rotate it, right? Rotate it in this direction. So when you rotate it, it would be like this. You get this kind of a thing, right? It's like a cup, right? When you rotate it, it's like a cup. Now, you need to find this, right? So this is your R. In the previous one, this is your R. Now, to find this one, what you have to do is you have to write, x in terms of y, right? So what typically you do, you take the inverse of this one. So when you take the inverse of this one, what do you get? Then you get x here. Here you get log e y, right? So then what do you get? Okay, so don't do that way. So we can do easily in this way. So x is equal to, you need to find x, right? So x in terms of y. So x is equal to e to the power y. So that's that way is easier. So now here you are writing x in terms of y. So that's true. When you're writing this one, you have to write x in terms of y. When you need this, you need y in terms of x. Right? So this one is nothing but y in terms of x. So this is all good now. Now this here is 0. What about y here? What is the upper boundary? When x is equal to e, what is y? y1. Okay, so my volume now pi r squared. My r would be x of y, right? X of y squared dy 0 to 1, and that would be pi 0 to 1 is going to be e to y dy. So it is going to be pi divided by 2 e to y 0 to 1. So pi divided by 2. If you put 1 here, it's going to be e2. If you put 0, it's going to be 1 minus 1. So that's the answer. Okay, so this question should be pretty easy. Now about x-axis. So it would be, now you don't have to draw, you can do it mentally. 0 to pi divided by 2, 3 sine 2x dx. What you are mainly looking at is this x, and then there should be a function of x. Y should be a function of x, and the y as a function of x is given. Why? Because this is y of x. So now, okay, before I forget to put square here, I will do that. So now this should be 9 pi 0 to pi divided by 2 sine 2x, the whole thing is square dx, right? So okay, calculate that. So if you calculate that, so it's going to be 9 pi 0 to so 0 to pi divided by 2 here. Okay, let's do that. So 9 pi squared divided by 4. Okay. So that part is fine. Okay, so now this one. Okay, so the curve y is equal to 2 sine inverse x, where x is between 0 and 1, 0 and 1, is rotated about y-axis to form a solid of revolution. Find the volume of the solid. Okay. So if you try to plot this, this should be like this, right? So x0 to 2, sorry, 1, 0 to 1. If x is equal to 1, if x is equal to 1, what would be your y value here? So that means 1, 2. If you put 1 there, it should be pi, right? If you put 1 here, sine inverse 1 is pi divided by 2. Pi divided by 2 times 2 is pi. So that means this guy is pi. So this is your upper boundary, this is your lower boundary, 0. And this is revolving around y-axis. So it's going to be like that, right? So you need this guy. Okay, so now we'll stick with the fundamentals. Now, v is equal to pi. You are revolving around y, so it should be dy. So this is a function of gy then, squared, right? So, but what we have here is a function of x, because this is y is a function of x. So what we can do, y is a function of x now. So it's 2 sine inverse x. So what I will do, I will move 2 to the other side. Then you get this. Then this is sine inverse. So I get x now sine y divided by 2. Now I'm satisfying my condition. So now x is a function of y. So exactly, I'm satisfying that here. See? Now what I get here, pi. Oh, I forgot to put the boundary here. Now the boundary would be 0 to pi, because this is pi here. So 0 to pi. So my function would be sine y divided by 2 square and then dy. So okay. So this can be written as pi divided by 2, 0 to pi. You can use the double angle concept, y dy. So you can use the calculator or you can just do it in here. So that would be pi divided by 2. Here you get y. Here you get sine y minus sine y. Right? And then you have the boundary 0 to pi here. So if you put 0 to pi, you should get pi divided by 2 here times sine pi is 0. Yeah, so it's going to be pi. So pi squared divided by 2 should be the answer. So here, so if you have a ellipse, right? So this one would be minus a to a. So that is what is saying here. This is y associated with y. So it would be b to minus b. Right. Then you are revolving around x-axis. So if you are revolving around x-axis, so your equation would be dx here, and this should be a function of x squared. So what is the related boundary to x? Minus a2. Then this should be a function of x, right? So to get that as a function of x, what you have to do is you have to subject y squared. So if you do that, you would get b squared 1 minus x squared divided by a squared. So that would be minus a to a. So Directly you have y squared. You don't have to take the square root and again square it, right? So you have fx squared already here, y squared. So it would be, and this is a function of x, it would be b squared minus b squared divided by a squared x squared dx. So I'm not going to do this integral, so it's very easy to do. So b part, now y-axis. So that would be again pi dy here. So you have to have the boundary associated with y. So that would be minus b to b. So then this is a function of y, g of y. So you can see that from the equation. So you subject x squared here. So when you subject x squared, you get a squared 1 minus y squared divided by b squared. That makes sense. Why? Because this is a function of y, because you have all y's in the right hand side. So it would be pi minus b to b, a squared minus a squared divided by b squared, y squared dy. So that would be the answer to that.